Hi, in this video I'll teach you what is a differential equation, what's a solution, or what is so-called general solution for a differential equation. Let me start with just very basic fact that what is an equation? When we say we have an equation, don't forget the differential. When we say equation, the one that you have worked with, it is an equality with an unknown. So we have an equality and we have an unknown. Usually we denote it by x. And then what is the goal? Well, the goal is to find all values of x which satisfy the equation, the equality, satisfy the equality. It's called the solution or a solution for example, we can have linear equation like this, or we can have what's called quadratic equation when a is non-zero. So for those ones you can actually find the solution, something that satisfies these equations. In other words, you have a recipe or a formula which gives you all the possible values. So in this case, the first case, we know that if we isolate x, we can solve and we can find all the solution. In this case, there's only one of x. How about this one? Well, in this case, in general, we have a formula. So if someone gives you such an equation, you have a formula called quadratic formula, and you just need to write the formula, plug in everything, and that gives you all the possible values. It can have two, none, or one solution. Well, then that brief introduction going to equations, now one can say, okay, how about differential equation? What is a differential equation? Well, it is an equation. It means that there will be some equality somewhere whose unknown, usually we denote it by y, is a function of a variable x. In other words, what we are looking for differential equation is the function. What function satisfies this equation? But that's not all. You have to also know that the word differential imposes something there. The equation have x, y, and derivatives of y. So first derivative, second derivative, and so on. Let me just write an example here. You'll see, for example, an equation of this one. Y prime is equal to 2x minus e to the power x. Or y prime equal to y. So we are basically looking for functions in x which satisfy this thing, and function of y whose in x whose derivative is equal to itself. So these are examples of differential equations. Okay, so if those are the examples, how about the solution? So what are we looking for? So what is a solution of a differential equation. So the nature of the unknown here is a function. So the solution is a function y equal to f of x, which satisfies the equation, the differential equation. Differential equation. In other words, the differential equation basically gives you a relation between the function, its derivative, and the independent random variable x, and a solution of that differential equation is a function which has the same relation. So for example, so these are examples, solutions for the function. For example, y equals to x squared minus e to the power x is a solution for 1. Why? 1, I mean this differential equation. Why? Because if you differentiate it, you get 2x minus e to the power x, and that's exactly what we have there. Or y equals to 3e to the power x is a solution for the second differential equation. This one means what? Means that if you differentiate it, you get exactly the same function back. So it means that it satisfies this differential equation. So it is a solution for that differential equation. Well, as you may notice here in these examples, a differential equation may have more than one solution. For example, you can see that if I put plus 1 here, that's also another solution. So that's where the new terminology comes in. What is the general solution of a differential equation? What is the general solution? Okay, so let me just write this down. Well, in general, a differential equation has not only one, two, but a family of solution, has a family of solution. The formula in x and y, which gives us all the possible solution, is called the general solution. Well, for example, in the examples we had, y equals to x squared minus e to the power x plus any constant. You see, there is a constant here, so it means that you can change that constant, get different solution, and all the solutions are given by this. This is the general solution for y prime equals to 2x minus e to the power x. Or for the second one, you see we had 3 here. You can change it and put any constant number. Y equals to c e to the power x is the general solution for the differential equation 2, which was y prime. The derivative of y is the same as itself. See, to check something is general solution, you just need to check if it satisfies the differential equation. Here, y is a constant times e to the power x, so its derivative is going to be the constant times e to the power x, which is equal to y. So that means that all such functions satisfy this equation. Well, then how we find it, those are the cases that we will study later. But before we move on, let me just put one more thing, initial condition. Well, as you can see, a differential equation may have more than one solution. Actually, they may have a family of solutions. So when we have general solution, it's not just one function, it's a family of functions. Sometimes we need to add one more condition to fix very specific function out of the general solution. So to fix a function which is a solution of a differential equation, we need to impose more conditions. The condition which is called initial condition, the extra condition which gives value of y and its derivatives at a point is called an initial condition. And the solution that satisfies that is called particular solution for that condition. For example, the first differential equation that we had was y prime equals to 2x minus e to the power x. Yes. Now we can set an initial condition there that y at 0 we want to be 1. So we are not interested in only this equation. We also want this to be satisfied. So all the functions which satisfy this thing, we know that are of this general form. We found it up there, yes, this one. Y equals to x squared minus e to the power x plus a constant. But if you add this condition there, it means that see what is the value of y at 0. So 0 squared minus e to the power 0 plus c. This guy needs to be equal to 1. And that means what? Negative 1 plus c is equal to 1. And that means that c needs to be 2. Means that y equals to x squared minus e to the power x plus not c but 2 is the particular solution for now this one. Not only satisfies the differential equation but also satisfies the initial condition. For the second one, let me do another example. Y prime equals to y. Let's say we have y at 1 equals to 4. We know that all the functions satisfy the equation. We have the general solution for this example. It's c e to the power x. Then you want the condition, this condition also be satisfied. So it means that y at 1, which is c e to the power 1, needs to be equal to 4. That means that c e is equal to 4, and that means that c needs to be 4 over e. This has the meaning that y equal to 4 over e. Instead of c, I'm putting that specific value, e to the power x, which is the same thing as 4e to the power x minus 1, is the particular solution for now this other one. So we need to study differential equations in details and make sure that, well, okay, these guys are, we understand what are they, we have recipes or formulas to solve them, and we can add more condition and find particular solutions for the given differential equation.